So sometimes, especially when I don't have a whole bunch of powers around, I prefer a tactic where I keep my expressions in a fraction. And instead of rewriting using only negative exponents, I rewrite using only the fraction to keep track of which things are where. So here's how that works. Variables with negative exponents that are in the numerator, we should write them with positive exponents in the denominator. And then, when you combine things from the numerator and denominator, in the end, variables end up with a positive exponent wherever they had the higher power. If m is larger, x to the m over x to the n is x to the m minus n over 1, and this is a positive number. If n is larger, then m minus n is a negative number. Its opposite, n minus m, is a positive number. And you can choose whichever one gives the positive power. So let's see an example of simplifying an expression this way. Let's suppose we wanted to simplify this expression using this method. And this expression is a good candidate for this method because it doesn't have any powers of powers. So we're going to rewrite this with positive exponents. And here's how. I'm going to go through one variable at a time. And if it originally appears with a negative exponent, I'm going to write it with a positive exponent in the other place. So this is x to the negative 1/2 in the numerator. That's x to the 1/2 in the denominator. If it appears with a positive exponent, I'm going to just leave it alone. Y to the positive 1/3 in the numerator stays y to the positive 1/3 in the numerator. Z to the positive 1/5 stays z to the positive 1/5. X to the negative 1/2 becomes x to the positive 1/2 in the denominator. Y to the 5/6 stays y to the 5/6. Z to the negative 9/10 becomes z to the positive 9/10 in the denominator. X to the negative 3/4 in the denominator becomes x to the positive 3/4 in the numerator. Y to the negative 1/6 in the denominator becomes y to the positive 1/6 in the numerator. Z to the positive 1/2 in the denominator stays z to the positive 1/2 in the denominator. X to the negative 5/4 in the denominator becomes x to the positive 5/4 in the numerator. Z to the positive 3/5 in the denominator stays z to the positive 3/5 in the denominator. Okay, now everything has positive exponents. Now I'm going to put together all of the same variable that I see in the numerator, put together all of the same variable that I see in the denominator. So in the numerator, I see x to the 3/4 and 5/4. So I'll have x to the 3/4 plus 5/4. I see y to the 1/3 and 5/6 and 1/6. And the only z I see is z to the 1/5. In the denominator, I see x to the 1/2 plus 1/2. Oh, and that's it. I see z to the 9/10 plus 1/2 plus 3/5. Did I get everything? Oh, I did get the z to the 1/5. I got everything. Now I'm going to actually go through and do this addition. 3/4 plus 5/4, that's 8/4. That's 2. 1/3 plus 5/6 plus 1/6. I don't want to do in my head. That's 4/3. And then I've got z to the 1/5. In the denominator, a half plus a half is 1. And 9/10 plus a half plus 3/5. I don't want to do that one in my head either. 9/10 plus a half plus 3/5. Oh, that's 2 exactly. So that's what we have. And now we want to combine things from the numerator and the denominator. X squared over x to the 1, that's going to be x to the 2 minus 1 in the numerator, since 2 is bigger than 1. The only place I see a y is this y in the numerator. And then 2 is bigger than a fifth, so I'll have z to the 2 minus a fifth in the denominator. So I'll have just x to the 1, y to the 4/3, over 2 minus a fifth I'm not keen to do in my head. 2 minus a fifth is 9/5. And there we go. This expression simplifies to this expression. You can use either this method or the one from the last video, whichever one you like better. For this next problem, I want you to practice using specifically this method. Simplify this expression by first writing everything in terms of positive exponents. Pause the video and try this now. Alright, so first I'm going to go through, and everything I see with a negative exponent I'm going to rewrite with a positive exponent. Everything I see with a positive exponent I'm just going to copy over. X to the negative 1/2 becomes x to the 1/2 from the denominator. Y to the negative 1/3 becomes y to the 1/3 in the denominator. U to the positive 1/4 stays u to the positive 1/4 in the numerator. X to the positive 1/4 stays x to the positive 1/4 in the numerator. Y to the negative 2/15 becomes y to the positive 2/15 in the denominator. U to the positive 3/8 stays u to the positive 3/8 in the numerator. X to the 11/4 stays x to the 11/4 in the denominator. Y to the negative 4/5 becomes y to the positive 4/5 in the numerator. And u to the negative 7/8 becomes u to the positive 7/8 in the numerator. Now I'll combine things in the numerator, combine things in the denominator. By the way, I want you to notice something about how I'm writing this. I'm putting my numerator on one line, my denominator on another line, and I'm leaving an empty line in between them. That's so that I'm not writing exponents on top of each other. If I try to write this any smaller or closer together, it's going to be hard to read. Alright, in my numerator, I just see the 1x. I just see the 1y. And I see 3 u's. U to the 1/4 plus 3/8 plus 7/8. In my denominator, I see x to the 1/2 plus 11/4. And I see y to the 1/3 plus 2/15. Going through and actually doing that addition, I've just got x to the 1/4. I've just got y to the 4/5. I've got u to the 1/4 plus 3/8 plus 7/8. Oh, That's 3/2. X to the 1/2 plus 11/4 13/4. Then y to the 1/3 plus 2/15. That's 7/15. So let's see. 13/4 is definitely bigger than 1/4. My x's go in the denominator. 4/5 I think is bigger than 7/15. And u just stays u to the 3/2 because I haven't got a u in the denominator. 4/5 minus 7/15. That's positive, so I was right about which one's bigger. Oh, it's 1/3. And then 13/4 minus 1/4. Maybe we could do this one in our head. That's just 3. And that's what we get. This expression simplifies to this.